7 had all of those different word problems. We had, the economics problem, like with the cost and the marginal cost. If I'm talking about a marginal cost, what do you have to do? What is marginal cost? Okay, sounds like we need to do an example. So let's say I am just completely making this up off the top of my head, okay? So just be very aware of that. Okay, let's pretend for simplicity's sake that's our cost. If I ask you to find the marginal cost of producing 3 items, what would you have to do? Derivative. You have your cost. If I talk about marginal cost, that's how the cost is changing. That's just your derivative. So the derivative would be 30x plus 2. Marginal cost of producing 3 then, if you plug a 3 into that, and we get 92. So if I ask you to explain to me what that means, what would you say?
It's going to cost $92. Well, it's going to increase $92 every time you multiply it.
Right. It doesn't tell us what the true cost is, but it says when 3 items are produced, cost is increasing $92 per item. Doesn't tell me what it actually costs to make that many items, but it tells me how my cost will go up. So if I want to produce 4 items, I would expect my cost to increase by $92. Would it be possible to have a negative marginal cost? Yeah, what would that mean? The cost was going down to produce that additional item. On these, I often had you do compare so I had to do a comparison. We know, we just said when we produce 3 items, we expect our cost to be going up by 3. If I want to, or by 92, excuse me. If I want to compare that with the true cost of producing that many items, marginal cost tells you how the cost changes. So if I want to figure out how the cost changes, what do I need to do? Right. Plug in, I guess I should have been more specific, the actual cost, let's say, of producing that 4th item, right? Because that's what it's predicting. So we have to find the true cost of producing both 3 and 4 items. So if I plug these in, we're finding the true cost, so they go in the original. What do we get? Plugged in a 4, we get 238. So the true cost increase, if you subtract those, is 107. So that means the actual cost went up $107. We predicted 92. So our our estimate was a little bit off here. And that's typically going to happen. The higher your degree, the more accurate your prediction will be. You know, when we did these, we usually had like a 4th or 5th power, and our prediction was a lot closer. This one's a little bit off. Okay, so you guys remember doing those? Remember, we broke into groups, so somebody had the marginal cost. We did like the projectile type problem. You know, if you have a position, what's the derivative of position? Velocity. Derivative of velocity is acceleration. If I ask you when you reach a maximum or a minimum, what do? Set the derivative to 0. You know, if you think about throwing a ball in the air, it hits its maximum when it switches from going up to going down. So it's when your velocity is 0. So maximums and minimums velocity is 0. And let's see, we had like a chemistry problem and a biology problem in that day too, but those were all just taking equations and finding their derivatives and just really recognizing that a derivative was a rate of change. So that was section 3.7. On the quiz, I'd probably either put one of these cost functions or one of the like velocity problems on there. Section 9 was all of the related rates. So we have practiced quite a few of those so far. Do you have any specific questions or that you want something like, or do we just need general practice with related rates? I may do, I have a whole packet full of sample problems, but let's do let's do one of the ladder problems. So let's say a ladder 10 meters long is leaning against a vertical wall with the other end on the ground. I'm not writing all that down. The top is sliding down. When it is 6 meters from the ground, it is falling at a rate of 2 meters per second. How fast is the bottom moving away from the wall? Okay, so if I draw a picture here, I've got my corner wall, the ladder goes here. What do we know about the ladder? It is 10, it's a constant, it doesn't change. Okay, what about these? I said when it's 6 meters from the ground, so that's like your height. Can I go ahead and label that as 6? No, because what's happening is this ladder is sliding down, which makes the end go out. So those are changing, so they have to be variables. So let's just call it X and Y. Then we go back to the problem and we write down anything we can. So when it's 6 meters from the ground, so what variable would that be? Y. So when Y equals 6, it's falling at a rate of 2 meters per second. So that's the rate the top is coming down, so that's dy dt. Falling would be a -2. How fast is the bottom moving? So what am I looking for? Dx dt. Okay. What formula do we use? Pythagorean theorem. X squared plus y squared equals 10 squared. Or you just call that 100. When you do this derivative of x squared is 2x, and we put a dx dt with it. Derivative of y squared is 2y dy dt. What's the derivative of 10 squared or 100? 0, it's a constant. Do I have everything I need to plug in here? What do I need? X. But we're looking for x at the instant when y was 6. So the x at that instant would be an 8. So then if we plug in 2 times 8 dx dt plus 2 times 6 times -2. So my dx dt would be 3/2. And units, the units on x were meters, the unit in time was seconds. Okay, just make sure, really kind of helping you guys yesterday, the things that you're struggling with, if you're not drawing a good picture and labeling your variables, then we tend to have problems. The other thing you have to watch when your rates are positive and when they're negative. You know, if you had, like, talking about a rectangle, if I said the area was, or let's say I'm shortening the sides at a rate of 2. When you shorten it, would your DAD or DL dt be positive or negative? Negative. But if you were stretching it out, it would become positive because it's getting bigger. If you're talking about like an ice cube melting, then the rate that it melted would be negative because it's getting smaller if I'm talking about the volume of that ice cube. If I'm talking about like filling a tank of water, then the volume of that, as I fill it, it should be increasing. If I have a tank of water and it's got a hole in it, then the volume is decreasing. So just remember, increasing positive, decreasing negative. Okay, so there's a related rates practice. Last thing I wanted to mention, this is not on the quiz, but I'm going to give you a review handout in a minute, and I put it on the review handout because we did it right before Christmas and I don't want you to forget everything. So, the last thing we did before Christmas was the derivative of logs. So I threw a couple log problems on here just for practice. They're on the review, it's not on the quiz tomorrow, but I still want to make sure we know how to do it. So let's say I said y equals the natural log of 3x plus 1 to the 4th. How did you do the derivative of a log? Remember the rule? Look it up if you need to. Section 3.6. So the derivative of this, you do 1 over the argument, which is the thing you're taking the log of. But we have to also still apply our chain rule. So 1 over the argument times the derivative of the inside. So how would I do the derivative of this? Times 3. We have to do the chain rule within the chain rule. And then if we clean that up, that's a 12 times 3x plus 1 cubed over 3x plus 1 to the 4th, which reduced to 12 over 3x plus 1. Let's do another one. Okay. How would I probably want to rewrite this? Either I'm going to have to do the quotient rule, or you could write it as natural log of 5x to the negative 1 power. What do you guys prefer? Quotient rule or negative power? Okay. So when you do the derivative, exponent comes down, inside stays the same. Subtract 1 from the power, so now it's a negative 2. Times derivative of the inside. The derivative of the natural log of 5x. Derivative of a log is 1 over the argument. And what else am I going to have to multiply by? The derivative of 5x, which is 5. Okay, let's clean this mess up. Ooh. Alright, here my 5's cancel. I have a negative 1. Since this is a negative power, I could move it to the bottom. You don't have to. And I have an x. So that's my final answer. Do we need to do another log derivative? Yes, no, no? Okay. So that's my review for you, and I have a